So there are many, many different solutions out there. Some of them are what we call optimistics. Some of them are what we call zero knowledge. And a lot of these solutions, they are meant to allow you to do things that you would do in a blockchain anyway. You just want to do it cheaper and faster, right? In our case, we want you to be able to do stuff that is utterly impossible to do in the blockchain right now. In our rollup solution, what you have is, instead of having a Cartesian machine in which you feed some input, you boot the machine, it runs, processes it, produces some output, and then dies, right? Imagine now that you have a machine that keeps running. And so you feed it input, it produces a few outputs, and then it keeps running, and you feed it more input, it produces some outputs, and you keep doing this, right? So in a sense, the roll-up solution is feeding data in and extracting data out of this Cartesian machine that now behaves as a server. So you can imagine that now you have an actual server running inside this Cartesian machine, and the way it interacts with the outside world is via these input-output packets that go through the rollup. So they have the advantages of the rollup in which, you know, it's cheaper to send inputs to this machine because they get aggregated together. And so you amortize your cost of interacting with this machine, both in terms of money, but also in terms of time. But really the magic is that now you have a machine that behaves as a server. You can actually have a web server running inside a Cartesian machine, and you can send via the rollups a request, and it will produce the response on the outside. And it's not like a standalone, it's like an actual, has a persistence of state throughout the computation. So it remembers what it was doing before when it receives the new input, and that frees the programmer in many wonderful ways.